Hi, I'm Gary Sharp. Welcome to the HazMatIQ by Federal Resources Chemical of the Month. This is our First Responder FRO edition. Let's start off by reviewing the system. Start off on look at chart number 7, and let's talk about the 4 steps. Step number 1 is size up. If we have the chemical's name, we're going to size it up using the first name of the chemical. If we're responding to an incident where we don't know the chemical's name, we're always going to use the above the line size up, which is the worst case scenario. Step number 2 is as we're responding, we're going to try to get more information using a container shape or a placard. Step number 3 is verify. If we have a chemical name, we're going to look it up in the NIOSH Pocket Guide and verify the hazards based on the chemical physical properties. And step number 4 is we're going to make entry into the hot zone to either perform a rescue or conduct a recon. This month, our scenario is a leaking rail car in the rail yard. When we're dispatched, we're going to use the above the line size up, and we're going to assume the product is a gas with a hot zone of 300 feet. The vapors are heavier than air. It is flammable. It has an LEL, a UEL, and a flash point. It could polymerize. It's an acid with fluorine in the formula. It's radioactive and it's toxic. Once we arrive at the incident and we set up upwind, uphill, the responders are going to dress out and turn out gear SCBA and take all of the meters in the safe kit, including their rad meter, their F and pH paper, their temperature gun, and their CGI. As they make an entry, if there's no rescue, then they're going to conduct recon. They're going to try to see if they can find out more information about which rail car is leaking. As they go down range, they can see this rail car in the distance. Now initially, you might not be able to see the name or the placard, but just based on the shape, we can eliminate some of the hazards. Go to chart number 3 and look to see which rail car looks like the one in the picture. If you'll notice in the picture, at the top of the rail car, there's a single dome. There's not individual valves that you can see. So on chart number 3, scroll down and look at rail car number 7. This is the one that best matches the picture. And the hazards based on this silhouette is flammable, toxic, corrosive, polymerizes, and forms peroxide. You notice the hot zone is 300 feet because what comes out of this car is always going to be a gas. The correct PPE for the first responders is turnout gear and SCBA. And the possible meter readings that you could expect based on this rail car shape is you should get negative rad readings. Your pH paper could change red or blue. Your F paper could change from pink to yellow. You may get a temperature increase, and you may get CGI readings. As we continue to get closer, the responders are going to be able to see the name stenciled on the car as well as the placard. If you have a choice of using the placard or the name on the car, we want to use the name on the car instead of the placard. It's more specific. The placard's only going to get you into the hazard class where the name's going to let you look up the chemical physical properties of a specific chemical. In this case, you can see it says non-odorized liquid petroleum gas. So if you take your NIOSH guide, let's look up LPG, go to page 187 in the NIOSH, and then we're going to verify the chemical physical properties that are listed on chart 7. So on chart 7, all you're going to do is verify that the size up that we're using is correct. If you look on page 187, start with physical description. We said it was a gas. Is that correct? And it says it's a liquefied compressed gas. So we're going to continue to treat it as a gas. Is this possibly an explosive? Look at the guide numbers. And on chart 7, it tells you the explosives are guide numbers 112, 113, and 114. So go up to the DOT box. The first 4-digit number, that 1075, that's the 4-digit number that would be in the placard. The 3-digit number is the guide number. That's not one of the explosive placards. Next, is it radioactive? Our chart said that there shouldn't be a radioactive product in here. We're going to verify it again by looking at the guide number. Things that are radioactive will have guide numbers 161 through 166. So guide number 115, I'll cross off the radioactive hazard. Now, could LPG polymerize? The 3 places we're going to look for polymerization clues, look up in the formula. And in this case, because LPG can be a blend of both propane and butane in different concentrations, they're giving us different formulas. All we're looking to see is, do any of those formulas have an equal sign? There's none there. We look at the guide number, the 115, and we're looking for a P afterwards. The DOT puts a P after the guide number if it polymerizes. There's no P. Now go down to the bottom of the page and look at incompatibilities and reactivities. We're looking for anything that says may polymerize, could polymerize. So I look in all 3 spots and I don't see any indication that LPG would polymerize. And remember, I don't need all 3 clues. If any one of them is present, I would treat it like it polymerizes. So I'll cross off that hazard. When it comes to the F, look back up at the formula. The fluorine, I'm looking for a single capital F in the formula. So there's no fluorine across that hazard off. Now pH, trying to determine if LPG is an acid or a base, if it's corrosive. If you look in the book, it doesn't tell us acid or base. Now because we're probably familiar with LPG, we know it's not corrosive. If we weren't familiar with the product, we would continue to assume that our size up is correct, that it's an acid, and we'll verify it with our pH paper. When we make entry and we tape the pH paper and F paper up on our mask, if it changes red or blue on our mask, we'd know that it's a corrosive gas. If we have to pull it off and dip it in the liquid, it changed red or blue, we'll know it's a corrosive liquid. Now the next hazard is flammability. Go down and look at LEL and UEL. And you notice there's different numbers there for both the propane and the butane, because remember that the LPG could be a blend of the two, and it's really not important whether it's 2.1 or 1.9. It's the fact if there are numbers next to LEL and UEL, we're going to treat the product like it's flammable. Now look up at flash point. It says Na, gas. Now don't assume that this means that the gas is not flammable. Remember that flash point applies to liquids. Flash point is the temperature that a liquid becomes flammable. When you go out and barbecue, you never have to preheat your propane so that it becomes flammable. Remember the science of it. When you heat a liquid up, it makes more vapors. You never have to heat up a gas to make enough vapors because it's already a gas. So gases are always going to have Na for the flash point, but if there's numbers next to LEL and UEL, look what it says below the LEL, UEL, flammable gas. So we'll continue to treat it like it's flammable. Now we sized up that these flammable vapors were heavier than air. Look at, on the left-hand side of the page, go up to molecular weight, and it says 42.8. If air weighs 29 and this weighs 42, all of these vapors are going to be heavier than air. They're going to accumulate low-lying areas, may spread out and find an ignition source. Now look at the solubility. Is propane soluble? If these vapors were moving towards a populated area or toward an ignition source that we couldn't control, can we use water to our advantage? Look at the solubility, and in this case the solubility it listed as insoluble. So we can still use water, but in this case we're not going to absorb it. If that solubility had been 10% or more, a fog line would absorb the product. When the solubility is less than 10%, we can use a fog line to push the product and try to redirect it away from the responders or away from a populated area or an ignition source. And the last one that we verify, is it air or water reactive? Look at incompatibilities and reactivities, and we're looking for the words air or water in that box. And it says that the LPG reacts with strong oxidizers, chlorine dioxide, but it doesn't say air or water. So we can cross that hazard off. At the end of the day, we just have to be able to describe the product and what hazards are present. So LPG is a gas that is flammable and toxic. The meter readings that we expect are listed on chart 3. We've eliminated the F, the pH paper, the polymerization, and we may see the readings in our CGI from the LEL. For more information about our first responder offensive course, go to HazMatIQ.com, and don't forget to tune in next month for our Chemical of the Month.